9. In this case, we are forecasting the prices of these laptop chips. We're given the data for the last 12 months of time, and in part A, we're asked to calculate a 2-month moving average. So go to chapter, go to moving average. We have 12 periods of information, and we want to use the most recent 2 periods for calculating. I'll also, because the question asked for this, it also says to plot, so I'll also click on the graph feature so you'll be able to see that. Now, what I did earlier was I pre-populated the numbers so that it would save us a moment or two of time. So we have the period of time from January to December. I've entered the data for the prices per chip, and you can again use the copy and paste feature. And the answer is, for the next period of time, which would be January of the next year, this is the answer for A. So the next period of time, the price of the laptop chips is 1.725 per chip. And that's simply taking the November, December numbers, totaling them up and dividing them by 2. And again, you could do that on your own if you wanted. Now, it also then asks us for a 3-month period of time. And I strongly encourage you to start with the copy and paste to start it from new. So you go to forecast, same thing. The only difference will literally be the fact that we're going to have a 3-period weighted average. We'll take the information from before and copy and paste it. Now you can see that the answer for part B is 1.7. It takes into account one additional period of time. So simply added October, November, and December, total them up and divided it by 3. Now, in part C, this is what is new. It wants to look at which has the better absolute deviation. So what I'm going to do in this particular case, we're going to look at the MAD. So the MAD for this one is 0.088. And I'll show you where that is on your screen. So what I'm talking about here is this number here. That's the number that you look at, the total at the bottom. All right, so 0.088. Now that's for, so the MAD is 0.088. Now the MAD for the 2-month is 0.075. So that number is here. And a smaller number is better. It measures the error. Would you rather be out by, in this case, the 0.075 is 7.5 cents. And you want that number to be, you like it to be 0. Or you'd rather be out by 8.8 cents. So it's actually worse. So the 3-month moving average is worse than the 2-month moving average. So in this particular case, the moving average MAD for the 2 periods is 0.075. The MAD for the 3-month moving average is 0.088, and less error with the 2-month. right? Now, in part C of this particular problem, we are going to use exponential smoothing. So we go to forecast, we use exponential smoothing. We have 12 periods of data. Move the graph again. If you click the graph on and you don't need it, it's no big deal. And you can always just ignore it. So I'm going to copy and paste this from this sheet here. And the alpha, the first one they want us to use, is 10%. So the MAD with an alpha, because we're going to change it here. And you could do this on 3 separate screens, but I'm just going to do it on the one. 0.1 is 0.0719. So that means you're out by 7.19 cents. So this one actually so far is the best compared to even the 2-month or the 3-month moving average. All you have to do next is change the alpha to 0.3 and it will recalculate. So the MAD at 0.3 is 0.0703, which is even better than 0.0719. And the final one, so you can see all of these calculations are quickly done for you. And this is again how you would do it in your job. You could do this by hand and you won't be able to keep up. Industry will say, well, we need those numbers. And we need them. If you're presenting this in a meeting and somebody just asks you to change the alpha, this is how easily you can do it. You can change it to whatever you want, and the software will calculate the numbers for you. So, which one is best? 0.5 is best because it has the lowest level of error. And one of the beauties of using the software is, what if I tried 0.6? Oh, that's even better. What if I tried 0.7? Even though the question doesn't ask, you can easily try different numbers without having to go through all of the calculations again. And it also, of course, does the forecast. So I was focusing on the MAD. So just to go back, the forecast in this particular case, and I'll write it on the screen. So just bear with me. So the forecast, so forecast for the 0.1, forecast for 0.3, and forecast for 0.5 is 1.7268 at 0.5 alpha, at 0.3 alpha, the number changes to 0.1, 0.7373, and at 0.1 alpha, the number changes to 0.770778. But because this one has the best MAD, you should use this forecast here. It is have the least amount of error in it. That's the best model. I want to be out by 6.64 cents or 0.0664 rather than being out by 0.0719. And so I'm going to use an alpha of 0.5 if I've given these three choices. And you will be given the alphas, so you just have to, plug in the numbers and calculate, or it will calculate it for you, I should say. But you need to know what it represents. And I've stressed throughout the course that this is how you're going to do it in industry. You're not going to sit there at your desk with pen and paper and calculator and do this. This example, if you were to try to do this example by hand, my estimate would be it would take you to do all three of them 45 minutes, an hour, a total waste of time. And you're more likely to make mistakes. All you have to do is make sure your raw information, your raw data is correct. And then read the results. And that's how you do it in industry. You get the reports, you need to know what the results mean. And more importantly is, how do I get the 0.0664 to be even better? Like I said, what if I tried an alpha of 0.6? Ooh, 0.06452 is even better. And there are more sophisticated ways, by the way, to get the alpha. There's some techniques so you can just get the exact number right off rather than the trial and error method. But for our purposes, just calculating this is as advanced as we're going to go. But it's way simpler to do it this way. And this is how it's done in industry. Thank you for listening.